So I wanted to just provide an update to what we've been up to. So I'm always amazed when I look back at our wiki and find written these things down. I hope we'll be doing what the plan is. So it's really good to look back at the past. This was on there. We really, part of this group is really to be a resource for all of Manakin's like genomics and things. And so we want to be able to dive into genomics. Make sure it's available for maybe if we haven't done some of these. And really, we want to keep a balanced view and approach to keeping both specific project goals and individual research, but also wider projections of understanding these questions about selection. That's sort of the big picture. We've actually made a lot of really exciting progress, I think. We started off by improving the MANACUS genome. Nice assembly of that. I've tried to list the people who have really contributed either to financially or working on the assemblies themselves. Correct me on that. We've taken different approaches throughout, so the landscape of genome sequencing has changed, and the amount of money people have put in has also has varied. So sequence some very expensive genomes, and we've also done some very inexpensive. So I'll talk about that. We have a genome for Cauda, and most recently we have the Panama genome that's Baldwin. So we have 4 Manakin genomes assembled and complete. That is very exciting. We're playing birds, and so I think this idea of the model play is really happening. We also have got some data shared with us from Flycatcher that we're using analysis. Really, most likely, the first paper that we're going to work on will be an analysis of this set. I'm not going to get too much in the weeds about the technology, the details of these assemblies, but this number is kind of a metric of how well assembled the genomes are. Many of you that don't work on genomes might not know this, but when you hear that you sequence the genome, it's often not really a complete genome. They're broken into lots of pieces. Fewer pieces, the better. The bigger this number, really the fewer pieces. And so we have our model system genome. This is the original genome. And you can see some of our more recent genomes are doing very well. This triplet genome, where we use a hybrid approach with PacBio, long-read data, and Illumina data, has turned out really extremely nicely. And this Neoplasma genome, where we use the new approach called 10x sequencing, less recommended than the last RCN, I think, also yielded a nice genome. And these genomes are now costing us like $4,000. So it's something that we've been able to do in individual labs that don't even necessarily have dedicated money. So we're trying to write a manuscript, but when we started I have a Google Doc that is development. We've got methods written for some of our genomes, so there's actually something there. I've started to draft an intro, but we don't know what the results are yet. So other than we have assembly. So I've started to draft an intro, but really some of the key analyses I think we'll be finishing up throughout this summer. One of the big sort of points that have slowed us down a little bit is trying to get these assemblies accession to GenBank for this automated annotation process I mentioned earlier. That'll give us predictions of what the genes are in these genomes, so we can start doing some of these that we really want to include in this. So I think in the next slide I'll have some opportunities for people to still get involved with. We're basically trying to look at how selection influences the genome, so both in the coding genes and non-coding sequences. Sounds like Morgan's made some exciting progress in this part. Morgan does not need the gene annotation, but that's going really well. Maud got involved in this partly because of her interest in ACE receptor evolution. That relates to some of these questions about forgivery that we talked about. And she too has found some interesting results I think that she'll be willing to talk about. But her goal is actually to do some functional assays of receptor binding, like that, to look at how these case receptors detect, particularly the sweet case that might be associated with fruit. And there's a lot more genes and gene families that people are interested in. Analyses of specifically that could go. We have currently one genome that is sort of in the middle of the process, and this one will be done very soon. College Boyle and companies for a FUCO genome. We use the 10x approach. The data are there. We just assemble it. This is another exciting opportunity. We've sort of partnered up with the big vertebrate genome sequencing project. Their goal is really to sequence the genome of everything. From our, I guess all vertebrates. But we're partnering in sort of the earlier phase of this to get a really high quality genome from Manakin. Our perspective as a representative of Manakins, and from their perspective as a representative of sub-Austin passerines with comparisons with things like that. And so the reason we decided to focus on this project is partly because of taking advantage of really all of Emily's work in the system. They have the potential access to pedigree individuals, which would be helpful for understanding genome structure and hopefully facilitate research going forward. And it adds a new genus to our list of access. The way we've come up with this money, this is the expensive range of genome sequencing. We basically put out, you may have seen lots of emails flying around the RCN about anyone want to throw in $100 to sequence this genome. Emily's paying for about half of it, and the rest of it is sort of coupled together from the rest of us. So we managed to put together this money. And the idea is that this would be a really, 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 really complete genome. So this will be our best genome by far when it's done. We're excited. Unfortunately, we're going to have to actually get all of this money to me in order to try. So I have to do the financial gymnastics in order to make this actually happen. So, but I think it's going to work. I actually think it's going to work. And it's going to actually happen. So if you've agreed to contribute to this genome, we're going to be working on this after the meeting, maybe during the meeting, figuring out what you need in order to pay me to pay Rockefeller to do the sequence. So basically, you have to send a check.
Not your personal checking account.
No, that would be much easier. So this is kind of cool. So maybe by next year, we'll be at a place something like this with genomes, which will be big. I also wanted to reflect back on the dimensions of biodiversity proposal that put some of these genomes in a broader phylogenetic context. This is I think another unpublished Manakin biology that was studying the grant mentioned proposal that Alice wrote before. In that proposal, we highlighted some species that we thought would be relevant to sequence. And so, it's pretty cool. The grant wasn't funded, but we've made some headway in distributing genomes among the tree of Manakins. But one of the other ideas that was in this proposal is sort of contrasting species that vary in their lex structure or the degree of ornamentation that complexity display. And so we've sort of maybe gone after some of the flashy ones, ones that people study a lot. We're trying to balance these two goals. So maybe some of these taxa where maybe they have less fancy displays or parts of the tree that we haven't really hit yet would be reasonable targets for future work. We did at ECU, we did a bioinformatics workshop that some of you were at. It was a lot of fun. That's a spoon build at Sylvan Heights Bird Park. We did a broad introduction to bioinformatics. Also included some R programs. My colleague who used to do our session. PCF file. If you don't know what a PCF file is, about it from us. So a bigger group of us now. Genomes, exciting. A lot of different groups, subgroups within the Manakin RCN have started to delve into transcriptomics. So that's another brand has been working on gene expression, how to social behavior network in the brain. And so, and a number of other groups have also started delving into genomics function. Mike Ron and his lab continue to work on the MANACUS hybridome and taking advantage of these. So what we want to do at this meeting really is these top three things I would say. First of all, is plan for this genome curation workshop, as this is now called. Moni and I were just talking about this, and this may actually intersect also with some of the data. Yeah, so with the data management part of this group, so the feature the bioinformatics intro crash course that you get. So this is a way of sort of storing code and keeping records of project updates in a coherent way. So bioinformaticists are very dependent on this framework, maintaining records, and basically lab notebooks that way. It'd be a useful thing for a lot of people to learn how to use it. We want to also work on this comparative genomics paper. We can provide more detailed analysis updates. But one thing, and this is definitely an area where people can still contribute. In particular, one thing that comes to mind is targeted analysis of genes of interest, which again relates to genome annotation. So my interest in genomes started from studying, I wanted to know about MHC genes specifically, and when the zebrafinch genome was being sequenced, I just looked at it, that single little cluster of genes, and I worked on that in detail, and didn't know anything else about how genomes were built. So if you have some gene that you want to look at, see if it's going to be in mannequins, have genomes, start looking, use brute force methods, you don't have to know bioinformatics. And so there are opportunities to start playing with this. And then we want to start thinking about what's next. How are we going to get additional genomes? Do we want additional genomes?